So today is the 26th. It is our third session, and today we're going to be talking about arrays and array methods. So starting with the built-in methods, we've already touched on a great number of these, but we're going to talk about them in a little more detail. So a method is a function bound to a data type. So that's a function that operates on these particular data types: strings, numbers, arrays, and objects. We've seen, for example, the toUpperCase method, which operates on a string. So it would be the name of the string as a variable or a value, a dot, and then toUpperCase, then the parentheses to actually call that method. So that belongs to that data type of string. If I tried to use toUpperCase on a number or an array, it just wouldn't work. So methods belong to inherent data types. You can find them inside of them by using the dot notation. Methods tend to perform actions on or are using the value being stored in that data type. The action performed may either mutate the data in place, which means to change without returning a new value, or it can not mutate the existing value and return what the value would be if it were to be mutated, the brand new value, which you could manually assign to the variable itself using the equal assignment. We've talked about mutation yesterday, and we gave examples of mutating and non-mutating methods. An example of a non-mutating method would be toUpperCase, because by calling it, it doesn't change the string, but rather returns what an uppercase version of that string would be. And push is an example of a mutating method that operates on arrays and it will change that array that it is acted upon and add that new thing to it. And instead, it just returns the new length of the array. So that's an example of a mutating method. So a few examples here. String methods, we have a dot concat. So you have the string name, dot concat, and then the name of another string inside of it. It can add two strings together. We also use the plus operator, which has the same effect. You'll find there is a lot of redundancy in JavaScript. So then it becomes more a question of what you would like to do, what standards are consistent with the code base you're operating on. Dot includes checks string that it contains another string inside of it. Actually, why don't I use some examples of these? So if I go over here into Safari real quick, and I go into our console, one thing I can do is I can take a string and see that it includes another string. So here I can look up, string includes. This means that it includes operating on the string data type. So you can see some examples of how it is being used. So here I have a string, the quick brown fox jumps over the lazy dog, and I can say, does it include the word fox? And if it does, it's going to return true or false. If it does, then it will return the former, otherwise the latter. This is you don't have to worry about this notation of if else. It's an alternate way of doing it. That's not what I wanted to fixate on though. But we could use examples here. I could say, I have a string hello, dot includes the letters HE. And it does at the very beginning. And if I tried to have it include something like she, well, that's not in that word. So it needs to find an instance of it somewhere within the string. And that's how you'd use dot includes. For dot concat, I could say hello dot concat space world, and it will return a new string, hello world. And the last one here for strings is dot trim. It chops off any white space characters at the beginning and end of a string. White space character would be a space or other characters that appear like or act like spaces. That could include new lines, which I can show some examples here. So if I look here at string.prototypes.trim, it sees it has all these spaces at the beginning and at the end. And by calling .trim on it, it got rid of those spaces at the beginning and the end. but it didn't get rid of the spaces in the middle. Those stayed in the string. So examples of white space characters include space, the tab character, and many others like it. All right. Oh. So an example usage of concat would return a new string code Platoon. There are number methods like toFixed. We've used that to specify where we would like to round our decimal number, which means to specify the precision. Precision being the number of significant digits available to us. ToString allows us to convert a number into a string. Remember, this belongs to a number. So if I were to try to use .toString on, let's say, an array, that may not work. It is possible that different data types could have methods of the same name, but these are different methods. So here's an example on pi. If I return it to 2 decimal places, we get 3.14 returned as a string, not a number. So, but you can always convert this to a number by casting it as a number. I did look into it. There is no toNumber method on string types, unfortunately. So you would have to write the word number in open parentheses, the string you want to convert to a number, and a closing parentheses to cast it to a different type. And you could do the same thing on a number with string. You could say, I could show an example here. I can go here. Oh, I can move this out of the way. I could say string on 3.14, and that'll give me a string of 3.14. And alternatively, I could say 3.14 dot toString, and that gets me the string 3.14. So like I said, there's often multiple ways to do the same thing in JavaScript, and whichever you choose to do is really more a matter of preference. All right. So now we're going to talk more about arrays and the methods that actually apply to the array data type. So we're familiar with arrays as a collection of values with a specific ordering. So the first index is going to have a value, the second, the third, and I can say what is the value at this particular location in the array. Well, we can do more than just check values in an existing array. We can always add new things to an array or remove elements from that array. So push is a common array that you've seen me use a few times now, and allows us to add elements to the very end of the array. This is an example of a mutating operation because it does not return the new array, it just adds it immediately. So I could go here, I could, if my mouse will show, I'm going to make an array 1, 2, 3, and I can say x.push 4. It returns 4 because the new length of the array is 4 elements long. And if I show you x, now it has 4 added to the very end of the array. So that's the push method. There's also a pop method, which removes the last element from the array. This is also a mutating method. So I don't have to have any assignment of any type. I can just say x.pop. It returns 4. You see, the length is now 3. So what it's actually returning to you is the value of what was just removed. So if I look at x, we have this here. It's removed the 4 at the end. And if I run x.pop again, it's going to return 3 because that's the value that it would have removed. And I can keep doing this. And now there's 2 things in there. There's 1 thing in there. Now, oh my God, 1 was just removed. So now it's an empty array. If I run x.pop again, it doesn't break. It just returns undefined because there was nothing to remove. So it still works just fine. All right, so in pushing, naturally, you can keep building your array indefinitely. Shift and unshift are very similar to push and pop, except instead of adding and removing to the end of the array, it adds and removes from the beginning of the array. So I can take my x array and I can say x.shift 4. Oh, hold on. Let me just, where we go? Yes, removes the first element. Oh, it's empty. We have to unshift to place something in there. Yeah, so there's now 1 element in there. Now I can choose to unshift. Let's say I want to unshift 7. So my new array should be 7, 4. It has 2 elements in there now. So that's prepending, placing at the beginning, or unshifting, as it's called in JavaScript, and appending or pushing to place at the end of the array. You'll hear these terms used interchangeably. And you see the words shift and unshift and pop and push, there's different words for them in different languages, but these will be understood well enough. And naturally, I can go in here and I can shift again to remove whatever's at the beginning. And it tells you I just removed a 7 from the array. And that means that now there should just be 4. So that's push, pop, shift, and unshift. Splice is an interesting thing. It returns a copy of the array with everything inside of it, but it's a different array. And we recently talked about comparing arrays and checking if arrays are equal. And to exemplify that, let's say I make 2 arrays. Array 1 equals the array 1, 2, 3. And array 2, I'm going to say equals array 1. So now looking at array 2, you see that it also has 1, 2, 3 in there. But let's say I want to push the value 4 to array 1. Okay. So now array 1 says 1, 2, 3, 4. Do you think that array 2 is going to be 1, 2, 3 or 1, 2, 3, 4? Because they both refer to the same underlying array. If I show you the contents of array 2, it has also been modified by the modification to array 1 because they're both referencing the same array. Okay, so if I wanted to make a copy of the contents of one array without making it such that what happens in one array happens in the other because it's the same underlying array, I want to make a separate copy of it with everything inside of it. So let's say I want to make a third array, array 3 equals array 1 dot slice. That means take array 1 and make a brand new copy of it. I don't want to make a reference to the existing array. I'm making a new one. So now array 3 has 1, 2, 3, 4 inside of it. Now I can go to array 1 and say I want to pop it. Okay, I just removed 4 from that array, but it's the same array as array 2, but not the same as array 3. So I can show you array 1, that's got 1, 2, 3, array 2, that's got 1, 2, 3, and array 4, oh my bad, array 3. Array 3 is still 1, 2, 3, 4 because it's a different array. It was a copy of it at that time. So changing the original array doesn't affect this because it's a completely different copy. So that's what slicing does. And splices can change the content of an array by removing or replacing existing elements and or adding new elements. So splice is actually very powerful. It does a lot of stuff. And one thing that might be more helpful, I can show you some examples, but before that, why don't we take a look at the documentation real quick? So I can go to string.prototype.splice. So it changes it by removing existing elements and or adding new elements in place, like it just said. So there are a couple examples here. What this is saying is on this array months, which contains January, March, April, and June, I want to add February at the first position. That's what this says. January, February goes here. So the first argument is the index at which I wish to insert. 0 says after that position, after and including that position, I want to delete 0 elements, and then I wish to add February. So this gives me the January, February, because that's the first index, and I place February there, and no deletions have occurred. Now this one says I want to go to the 4th index, 0, 1, 2, 3, 4, so that's June. And I want to, at that time, erase exactly 1. So that deletes June and brings us with just these. And then I want to add May. So May gets put at the end. So when I set the second argument to 1, that allows us to replace whatever was already there, because I deleted 1 and then added 1. But if I make it 0, then that allows me to insert it in between those two things. So here, this replaces the element at index 4. That's how this is so powerful. I can do both insertions and replacements with one single method. So June becomes May, as you see here. Naturally, I can also delete multiple. let's say instead of, let's say here, I wanted to delete 2. What that would do is at index 1, it deletes March and April, and then it makes February. So that's going to return January, February, June. So if I give this a run, yep, January, February, June. But if I 0, now it's going to be exactly what it expects. It's going to be January, February, March, April, June. Yep, and here we replace June with May because I said delete one element at the 4th index. So that's the splice method. I know there's a lot to unpack there. And if you want to see, you can add more than one element. You can just keep passing it elements here. So where you want to start, how many you want to delete, and then after the deletions you've made, which elements you wish to insert. And you can have as many as you want. All right. So that is the splice method. Next, we have the index of element, and it tells you the index. The index is the location. It gives you a number specifying the location in the array of where that element is found, the element being the value. So now I can go here, and actually let's look very briefly at the notation for index of. And see, there's like a long list of methods, and you can click them, and it'll explain to you what it does, give examples of it, and then explain what each of these parameters do in detail. And there's lots of examples to go off of. One of the reasons I absolutely love the Mozilla Foundation's documentation. So now let's look at index of. It tells you where it can be found in the array. If it isn't there, it's going to return -1. And as we know, arrays start at 0, so -1 is not a valid index. So here we have a list of beasts. We want to find where bison is located. The first instance of bison is at index 1. If I had bison in here twice, oh look, they do. They have bison at the very end. It doesn't return that one. Now I can specify where I would like to start searching in the array. That's the second parameter. I say start searching from index 2, so 0, 1, 2. I'm only searching in this subsection of the array. I'm like, where is bison? Oh, that's an index 4. 0, 1, 2, 3, 4. So that means if I know the location of the first index, let's say 1 here, I could take this whole thing, plug it in here, and add 1 to search for the second instance of bison. So, you can use multiple calls to index of to say, I want to find the second instance or the third instance or the nth instance of some particular element in an array. So that's the power of index of. You'll actually find that this can be useful in an upcoming problem that we'll be working on today if we have sufficient time. All right. And dot join joins all the elements of the array into a single string. All right. So that's an interesting one, is that it can take individual things in our array and combine them together. So let's say I have an array. Let's clear this here. Okay, I'm going to make an array, x equals 1, 2, 3. And here I could say x.join, and I want to join it with a space in between each one of them. So that gives me a string 1 space 2 space 3. I could instead place a comma in a space, so now it kind of looks like a stringified version of an array. Or I could place nothing in between to just combine them together. And this is really helpful when sometimes you want to take a string and you want to make it an array, do something to that array, then turn it back into a string. That's something that's very common to do in JavaScript, because certain methods that allow for some very powerful operations only exist on arrays but don't exist in strings. All right, there's actually another one, yeah, .splice. Yeah, .splice can actually be used on an array to get individual indices. So let's say I have, this particular string. If I were to try and splice it, well, that's not right. My bad. Splicing operates on arrays. What was it that I can use to turn a string into an array? I forgot what it was called. It's a very useful one to have. Oh, split, I remember. There we go. See, they all kind of sound similar: split, splice, slice. You know, the naming conventions take a little bit of getting used to. So I can say I want to split the array 1, 2, 3 into an array of strings 1, 2, 3. Then I can join it back into a string again. That's cool. But one cool thing is there's a lot of methods. Like you've seen, there's a giant list of methods that pertain to arrays, and you're not expected to memorize them all. One example is the reverse method, which can flip everything backwards. Then I can join it again. And just like that, I've reversed the contents of a string, but I had to convert it into an array to do so. So that's an example of where split and join are powerful combinations to use in tandem. All right. There's also for each, which allows you to execute a function for every element of an array. So execute a function for every element of an array. Let's make an example here. I have an array x. I can say x dot for each. I want to take an index. I want to take that particular value, and I just want to console log its value. I just want to print it to the screen. So now for every one of those, I said, 1, print 1, 2, print 2, 3, print 3. So that's another way of doing it. We could have just used a regular old for loop, but it's cool that we have options like this. And map. Map is a very powerful one that allows us to do something. It's kind of like for each, except instead of running a function, it takes whatever the return value is of that function you had and replaces what was in the array with that return value. So let's say I have this array, 1, 2, 3, and I want to replace it with 1 plus the value that was already there. So 1, 2, 3 could become 2, 3, 4. Again, I could have done this with a for loop as well, but let's say I want to x.map, take an index I, and return I plus 1. Now we have 2, 3, 4. Now actually that was a non-mutating function. You see x has not been modified, but we see what the modification would have been. So I can say x equals this mapping, and now x has been changed to 2, 3, 4. So that's an example of how you would use map. All right, I know that was a lot of methods I just threw at you guys. Do we have any questions about these methods?
Yeah, real quick, can you go over what map does one more time?
Yeah. What map does is it allows you, just like for each, it allows you to do something with every single element of your array. But instead of just running a function that can do something, it actually changes it changes the value at each of these positions. So I have an array 1, 2, 3, and I say for each of these individual elements, 1, I want you to change it to 1 greater than its existing value. So 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4. So this code, x equals x.map I to I plus 1, is equivalent to me making a for loop. Let I equal 0, I is less than x.length, I plus plus, and then saying x at the index I equals x at the index I plus 1, and then I could close it. And now I look at it and I got 3, 4, 5. So this was a fancy way of doing exactly this. But it took a lot less lines to do it, and I personally think this is a lot cleaner to read. So mapping is not essential. Everything that you could do with a map or a for each, you could do with a for loop. But you will see maps and for eaches they're very common, especially when you start working with React, which is a front-end library that you'll be learning in the cohort. So it's important that you're familiar with them at the very least. All right, were there any other questions? All right, So if you'd like to see more examples of any of these particular methods, you can find them on the JavaScript documentation. So you can find them within array objects. You can find them for any other data type. You can just go up here and search for what you want. If you, let's say you know that you want to find the shift method, you can look for array.prototype.shift. Click it, and it will tell you all about the shift operation which occurs on the array data type. All right. Yeah, and that's the end of our slides for session 3. I did want to touch on a question that was asked the other day on comparing objects. I did show briefly an example of how we would compare arrays, but we didn't really talk about comparing objects. I just said it was a similar process. So let's take a look at, oh, actually I already have it here. Compare. All right, so we can just look at this first part right now. You can ignore everything else. If I want to compare two arrays, like we already established earlier, when I say that this array is equal to this array, what that means in JavaScript is that they refer to the same underlying array, and these are just different names for the same thing. But if I want to compare the values in them to say that this is an array that contains the values 1, 2, 3, and this is an array that contains the values 1, 2, 3, whether it refers to the same array or a different array, I just want to know if the values inside them are the same. That is not something that exists in JavaScript by default, so we have to make it ourselves. So first of all, when it comes to defining that the values are the same, you know that they must have the same length. If the length of this array is longer than the other one, then they can't have the same values at every position because they have an unequal number of positions to have. So immediately, before even running any for loops, you can say it's false. This is also necessary. You have to do this because if you don't, let's say I got rid of this and array 1 was a lot longer than array 2, then I'm going to have a for loop that's going through this and then tries to access values outside of array 2. And that's just something you can't do. If I go here and I say x equals 1, 2, and I say, what is the third value in the array? There isn't a value. There just isn't a value there. In JavaScript, it just says undefined. In a lot of other languages, it will just break the program. It will stop working entirely. So always checking your bounds is a good practice to have. All right, so here I have the for loop. I go over the length of the first array, which we know is the same as the length of the second array, because if it wasn't, then it would have returned false by here. And it goes one index at a time. And it says if the value at I and array 1 isn't strictly equal to the equivalent value in array 2. So I'm checking each value at the same position. Is it equal? Is it equal? Is it equal? If I ever find one instance where it isn't equal, I can say these arrays are different. But if I got through all of them, I went through the entire for loop and I never found a single instance where that's true, I can return, yeah, the arrays are equal. And that's how we define arrays as being equal. So here's a couple examples of arrays here. We have an array 1, 2, 3 and a separate array 1, 2, 3. These are not the same value. I could have just as easily said array1.slice and that would do the exact same thing because they're not referring to the same array. They're two independent arrays. Here I have an example of an array that is different, 1, 2, 4, but the same length. A different array of a different length and an empty array. This is just me being very tedious with my tests to make sure that this is correct. So the first test I made is check is the same array equal to itself? It always should be, because it is going to have the exact same values. If that doesn't work, you know you're doing something wrong. The second one are two arrays that are referring to different underlying different data, but have the same values considered equal. That's what we defined our function to be looking for, so this should also return true. This exclamation mark means the opposite of. So if this returned false, then the negation of it would be true. And if it was true, then the negation of it would be false. So that's the exclamation mark, read as not or negation. So is 1 the same as 3? No, it isn't. I don't expect it to be, so I'm saying I want the negation of that. I'm expecting all of these to return true. 1 and 1, 2 for array 4. That is not the same as the contents of array 1, so that should return false, the negation of which is true. And 1, 2, 3 should not be the same as an empty array, the negation of which is going to be true. So if I run that for the first 1, 2, 3, 4, 5, I should see that they are in fact true. Actually, while I'm here, I can assert the fact that all of my tests are true, like they all passed. So now we know how to compare arrays. And it turns out our ability to compare arrays is crucial to our ability to compare objects, or collections of key value pairs. So one important thing about objects is that the order in which elements are, the key value pairs are declared within the object doesn't matter. So if I was to compare, A1, B2, that should be the same as B2, A1. Now, if I just take the objects as is, and one thing I can do is I can break it into 2 arrays, one of its keys and one of its values. So let's say I have that array, let's take object 4 as an example. Object 4 has the key A with the value 1, key B with value 2, and key C with value 3. One thing I can do is there is a method within the object class itself. It doesn't belong to the object prototype. It's not object 4 dot, but I can say object.keys object 4, which means find the keys in object 4. And that gives me A, B, and C, which are the keys in this object. Now, similarly, I can find the values for object 4. If it will load, there we go. And I see 1, 2, 3. So we extracted each of these components and put them into 2 separate arrays. So you could imagine that we have 2 objects, and I break it into its key array and its value array, and I say, are their key arrays the same and their value arrays the same? If both of those are true, then the objects are the same. But the thing is, arrays have a specific ordering. And the ordering in which this array is made depends on the order in which key value pairs are declared in the original object. So imagine I have a different object. I'm just going to call it, C3, B2, A1. The same as our original object 4, but all of the key value pairs are in reverse. If I were to say I want to get the keys of the object in question, here the array is in a different order, CBA. Now you can ask yourself, does ABC equal CBA based on our definition of equality? No, it really doesn't. So we need to sort the arrays so that they're in order. All right, so that's what we do here. Before we can even compare our arrays as being equal, we need to sort the objects. So one thing I do is I make here a new object that I wish to return, the sorted object in question. And I say, go through all the keys of the objects. But an interesting thing is that because it's an array, arrays have a built-in method called sort, which allows you to sort the array for you. So that's actually, it's really nice that that exists. Otherwise, we'd have to manually sort it ourselves, which can be a very tedious thing to do. So by calling sort on it, it converts CBA into ABC. But it's not enough to just sort the keys. We also need to sort the values by the keys. So that way, whatever corresponded with the 3rd position of the values array is now in the 1st position of the values array. And they all swap except for B, which is in the middle. So to do that, I say using our for of loop, which iterates over the keys of, which iterates over the values of an array, because this for ofs operate on arrays and for in on objects. So here I have the array of the sorted keys, and I say the result of our key, the result object we wish to return, we're going to create a new key value pair, which has the key and then the value that that key has in the existing object that we've passed to it. So here I can say, what is the value that corresponds with A? That would be the 3rd one in our values array. Actually, no, we're accessing it directly from the object, so the ordering is entirely irrelevant. but it will generate them in the correct order because I've done it in the order that it is sorted in the for loop, and then I return it. So I can demonstrate that here. If I use the sort object, let's say I have object here, and I say sort object on obj, it generates A1, B2, C3. And naturally, if I did that on object 4, it does the same as well. So now that we've sorted the object, we're able to check if objects are equal without regard to the order in which key value pairs are made. If I wanted to strictly check for the order in which they're declared, I could get rid of that sort object. So that depends on how we define equality. And that's another reason why JavaScript doesn't build it in by default, because what you and I might consider equal is a little bit different. Right. So now I create sorted variants of the objects that are passed, and I check that their key arrays are equal and their values arrays are equal using the isArrayEqual function that we made earlier. And similarly, I made some tests validating what I believe should and should not be considered equal, and assert that these are equal and these are not equal, and all of our tests did in fact pass. So that is how we would compare objects. I know that is a very tedious process. There are existing JavaScript libraries which do this for you, but it does not exist in the default JavaScript that you have. So when you're working in real web development, you're not expected to build everything from scratch. But in vanilla JavaScript that we're operating in, you kind of have to. All right, so that's how you compare objects. Are there any questions about object comparisons? No? Okay. With that said and done, we can get started on our exercises. All right, so the first exercise I want us to go over is the cold enough problem, which addresses control flow, which is our if-else branching. So the question is this: if the temperature in Chicago drops below -4 degrees Fahrenheit, school will be canceled. Write a method that takes in a temperature in degrees Fahrenheit and returns a Boolean value, true if school is canceled, or false if it is not. Right. Are there any questions about what this problem is asking? Any clarifications that you would like to have? No? All right. So I'm going to send the link in the chat. And I'll give us a good 10 minutes to work on this. All right. And I will see you then. All right. Our 10 minutes are up. I hope that was enough time for this problem. This is a warm-up problem, by the way. I do expect the difficulty of these problems to increase as we progress through this session. Do you guys think that we should have less time for the warm-up problems so we have more time to work on the more difficult problems later in the session? Or do you think that 10 minutes was sufficient?
I solved it in 8 minutes. I know once I got it, it was really, really easy, but I struggled to figure it out. But once I figured it out, I was like, it's really easy. But it took me 8 minutes, so I say 10 minutes is good enough for me. I don't know about anybody else.
Okay. We'll stick to 10 minutes for the warm-up exercises from now on then, as long as no one else objects to that. All right, so let's get started. The question is, if the temperature drops below 4 degrees Fahrenheit, school will be canceled. So we know the temperature given to us in Fahrenheit. So all we have to do is say, is the value less than -4? So I can simply return, is the temp less than -4? And let's write some tests while we're at it to make sure that it is in fact consistent with our expected results. And the next one was on 21.4. So we expect to see true and false. That's our expected outcome. All right, give this a run. And that works. All right, great. Do we have any questions about this problem before we move on? No.
So for this one, I did an if statement. I got the same answers, but it's just, I guess this is just a different way of you doing it.
Mm-hmm.
Okay.
See, when you have an if statement, and let's say here, I did if the temp is less than -4, return true. And then I could say, else return false. Although the else isn't required here because there's just one place for it to go. If I did this, the fact of the matter is temp less than -4 is itself going to be either true or false. So if all I'm doing is returning true, there are legitimate reasons why you would occasionally do this, return true or return false. Like for example, when I had the example earlier in compare, I would return false or return false in the middle here. But that's because I didn't want it to quit when it's true. I wanted it to keep going. But if I know that the program is going to terminate on a condition of something being either true or false, I might as well just return that thing in the first place. Because this is going to be either true or false. If it's true, return true. If it's false, return false. Returning the condition itself would have the exact same effect. And that is generally the preferred thing to do. All right, any other questions? No? All right. So the next problem on alphabet code. All right, let's see if I have that here. Actually, before I talk about that problem, I do want to, let me just find it first. There it is. There we are. I have a couple of methods I actually want to briefly touch on before we have you solve this problem, because I think it will help you dramatically. So first, let's pose what the problem is. Alphabet code. We need to write a method that takes in a single uppercase letter of the alphabet, A through Z, as a string, and returns the integer corresponding to its place in the alphabet starting at 1. So A is 1, B is 2, C is 3, so on up to and including Z being 26. All right, so there's something in computing called Unicode, and it's the idea that every single digit character, it's a string that's 1 letter long, that has a unique numeric representation, because underneath the hood, computers don't understand data types. They don't understand letters and characters, strings, arrays. All they understand are numbers, and it stores them in binary, 1s and 0s. And as a consequence of this, every single character has a particular number mapped onto it. And the fact of the matter is, alphanumeric characters are sequential. So A is going to be just left of B, C, D, E, F, G. You could make your own array that just has A, B, C, D. I could show very briefly how that would be done. Hold on just one second. I don't expect you to do this. I'm just going to show a brief example of what that Unicode table looks like. Let's say I want to see the first 100 characters in that table. It is string dot character from car code and to car code. So what I'm looking for here is called 2-character code. Car code at. We already solved cold enough. Yes, hold on 1 second. That's strange. Oh, my bad. It is stringed up from card code. You'll see what I'm doing in a second. So here we have a big table of characters, and it's really just a big array. At the first position, that we have some other characters which we can't really represent, but are important for computers. We have tabs, we have new lines, which is that character that's used to delineate new lines. We have spaces, exclamation mark, every conceivable character you could imagine in every single language, whether it's Chinese, whether it's English, every character system that exists has a number associated with it in this giant array. And that's what we refer to as Unicode. I was just hoping to show you a cleaner chart if I could. Yeah, this also includes emojis, by the way. I just wanted to see a Unicode table. Sorry, my internet's just a little slow. Yeah. Here's a better example of what I printed. It starts with some characters which are important for computers to work, but they don't necessarily have human readable representations. We start with some symbols, we have numbers, we have all the capital letters in order from A through Z. And remember how I told you there was a function that can operate on arrays to tell you what is the index that this is found at. So if I recall correctly, that was index of, finds the first instance of something. So let's go in here and take a look at the terminal here. And let's say I make an array of values from, let's say, A through Z, hypothetically. Values A through Z. I just took a subsection of that Unicode table. And I wanted to say, where is B located in this? Dot index of B. I'll tell you that that's at 1. So the idea is that you could solve this using an array utilizing index of. I want you to do it yourself. I don't want you to look at the code that I just used. And there's a reason I didn't explain it, because there are many alternative ways that you could do this. All right. And I do want to say there are much simpler ways to solve what I just did than the solution I gave you. There are 2 main functions which you might find helpful, and that is going to be string.from character code and character code at, and then a number specifying that value. So with that information and the knowledge of the index of method, I think you should be able to solve this problem. I'm going to send you a link in the chat and give you 15 minutes to work on it. Before I do so, do we have any questions about this problem itself? No. All right. I'm going to put 15 minutes on the timer.
Can you send that link to the one you just said? That would be helpful to us.
I'm sorry?
Can you send that link of the?
Oh, absolutely. Hold on. Let me just find the, I'll get the documentation for it. You might find that a lot better to look at. String.prototype.character code at. This is a very useful one to know. There's also the from character code. And the index of, which is another one you could use. And array.index of. There's also string.indexOf, which is kind of similar. It has a similar application. All right. So now that you have those resources available to you, I'm going to go start the timer. If I can go back to setting it to 15 minutes. I want to share the screen. And I want to share Safari. All right, can you see this now? Can anyone verify that they can see the screen?
I see it now.
Okay, great. Sorry, I didn't see your chat. Yeah, so like I said, and I forgot to start the recording a second ago. There's two main approaches that you could use here. One is make the alphabet array, get the index of that letter. So it's going to be starting from 0 and add 1. So A is at index 0. That's the first instance where A is found. You increment by 1 and you return 1. B is going to be 2, C is 3, and so on. But you don't need to solve
Just
it.
cut out.
Oh. Can you not see it, or can you not hear me?
You can hear, you just can't see it.
Oh, joy.
For me, it goes in and out, like it goes completely black and then slowly goes back to the screen and then goes straight back to being all black.
Okay, that is, oh, it says that I'm signed out. That does not make sense. Let's see if I can fix that. Okay, convert the previous recording. Can you see this at the moment?
It's working now.
Okay.
Oh, no, it just went back out again.
Oh. I don't even know what to do about that. How about now?
It's hard to tell. I think if you start doing something, it might be able to see if it's working again.
So I have here, I can just type something to see if you can see that. I made an array that contains the alphabet, letters A through Z. I'm using the index of method to find the position of the letter. And then I add 1 to it because indices, arrays start at the index 0, and I want them starting at 1. And I wrote some tests here for A, B, and Z respectively, and they all return true. So this is a perfectly valid solution. Can anyone not see this right now? Or
It cuts in and out.
Yeah, it's just way too glitchy right now.
Unfortunately, I don't have any solutions for that. Like I can try, I just restarted the share. I turned it off and on again. I've also been experiencing a lot of lag. Like I press a button and then I have to wait upwards of a minute before it responds. So it's taking a considerably longer to solve anything. Fortunately, it is being recorded, so hopefully you will be able to see the recording at the very least if you are having issues seeing it at this time. I don't really have any other option other than to keep going. I'll try to explicitly narrate everything that I'm doing though. All right, so the alternative to making an array and indexing it is to use that Unicode table I talked about earlier. Now, there is a built-in method that can take a letter and return its index in the Unicode table respectively, the value that is associated with it. So imagine I can go to the console here very briefly and say I want to look at the letter A, and I want to say car code should be from character code or car code at. Yeah, so it's A, it can be the letter dot car code at, and it returns a number. In this case, A is corresponding to the number 65. If I gave it B, you will see 66. You know, C is 67. And fortunately, those are all sequential. So all I have to do is subtract 64 from this value, and I'll end up with a collection starting from 1 all the way through. So instead of returning index of, I can ignore all of that, and instead I can simply decide to return the letter dot character code at minus 64. So that's a one-line solution to the alphabet code using the existing Unicode table. And once it's done typing it out, we'll be able to run those tests to verify that it does work. I'm going to try stopping and restarting the share because this is getting a little ridiculous. Nice. Even the video stream is lagging considerably. If I go back to sharing the screen. All right, so that's, can you guys see it now by any chance?
Yes, I can see it.
Okay. So I have the first approach here I've just commented out using the alphabet and using index of, and the second approach using car code at to get the number that corresponds with the letter that has been given in the Unicode table, and subtracting 64 because A is the 65th value on that array, and I wish to return starting from 1. So I can run this. And they all return true. So both attempts work here. All right. So it is presently 6:30. We should have time for one more exercise. Are there any more questions about alphabet code before we move on? No? All right. All right. The next problem, we can work on remove zeros. This is actually not, yeah, that's a good one because it does utilize, it says it's just types, but there are some solutions that can utilize arrays, which you might find very interesting. And I'd like to go over those as well. So remove zeros types. There we are. I actually have noticed one thing. When we have very long sessions, upwards of an hour or two, the Zoom call actually slows down considerably. So I have a feeling that ending and restarting the call might speed it up, but that'd be such a hassle at this point, and we only have 30 minutes remaining. So I'm just gonna see if we can tough it out. All right. So remove zeros. The name kind of gives it away. All it's doing is it is taking it's a function that takes a number and returns a string version of that it returns a number with all the zeros removed from it. So it returns a number. It takes like 1001, will return 11. This big number here, you get rid of all the zeros, you end up with this number. All right. Do we have any questions about what this problem is asking? You may find that using, you can use for loops, you can use maps, you can split it, you can convert it into a string and operate on the string. There's a lot of different approaches here. There might be some mathematical solutions here that don't require any conversions. All right, I'm going to give us a good 15 minutes to work on this problem. Let me just send the link real quick. Oh, someone said something in the chat. It's blinking again. Yeah, I'm sorry. I just hope that you can at least see the problem and hear what I'm saying. If it blinks now and again, not much I can do about that. All right, so you should have the link in the chat now. If there's no questions about what the problem is asking, then I'll start the timer. All right, so I'll see you in 15 minutes, and that should give us 15-ish minutes to work on the solution together. All right, so I'm going to start now. So to recap what I just said, there's two main solutions to this problem. One is I have a string, which I build to. I add the string version of the number that I'm looking at in the stringified version of the number. And then I add it if it is not equal to 0. And then I can convert that string back into a number and return it. The alternative is to use a method called filter, which can go through the array and select only the ones that do not meet a certain requirement. But we're going to solve the for loop variant first. So I can say is less than numArray.length because I want to go over all of them. Actually, a better solution would be to use a for of loop to go over the array. Oh, it's gonna keep on typing because there you go. NumArray. Oh, that's not what I wanted to type. All right, so I'm going to say let, in this case, it's just going to be a digit of numArray. And since here I can just say if digit does not equal 0, that's going to be the string 0, but since it's not a strict equal, it will also compare to the number 0. That's fine. On that condition, I can say, well, res equals res.concat with the digit that I've just found. So that means add the digit to our string. So we're building the string one digit at a time if it is not 0. All right, after we've gone through all of that, then I can return a number cast of that string. So I convert it from a string into a number. So I can return number on our result. Great. So now let's write one test really quickly. Console.log, remove zeros on 1001. I don't know why it's being so slow. I don't know if I'll have time to show the filter result. If I don't, I will show examples of it in the Slack. So this should return 11 because after removing the 2 zeros in the middle, I will have, 11, 1001, remove the 2 zeros in the middle. So I click run. That's interesting. Is it an of loop or a in loop? I always get those two mixed up. Actually, I'm gonna look it up on my phone because that will be a lot faster than trying to do anything on this computer right now. Okay, for in is for objects, for of is for values of an array iterator. Yeah, that should be correct. So let's look at it here. ToString. Oh, you know what I have to do? I have to split it. Nope, I did not mean to click abstract range. I have to say to split with no delimiters involved. So now I can click run. Yeah, and the result is 11. So it works. Are you able to see my screen? I've just seen people in the chat saying they couldn't solve this problem.
It'll come in and out.
Yeah, I'll see about posting this code on the Slack just to make sure you all see it. Right. Yeah, it looks like we're out of time. I will post the solution to this problem and the filter alternative solution in the Slack. All right. Are there any particular questions about this problem before we leave?
Yeah, maybe in the next session when we meet, you can explain this, how you did this, because I'm very confused on how you did this, to be honest.
Okay, I will make sure to talk about this in the next session. All right, I will see you all on Monday.